going. We're just going to start with some AET introductions on our side. I would also like to invite folks to enter into the chat if you'd like to introduce yourself and what school or district you're hailing from, like I just did. And while you're doing that, I'll invite Kristen to start off.
Hi, everyone. I'm Kristen. I work in marketing at AET Lab, so I work with Adam in running these events and some of the other things we do. And just want to let everyone know that this is recorded and we'll be sending out a copy of the recording tomorrow in your email. Thanks for joining.
Thanks. Mark, would you like to chime in? You might be off right now. All right. Well, I don't think we have any other AT folks on, do we, right now?
No.
Okay. Okay. Well, my name's Adam Zelny. I'm the application specialist with AT, and my main role is to help get systems that we sell to schools set up and running. And I work directly with the end users or you wonderful teachers on integrating those systems. And that sometimes can be as simple as, you know, here's a 3D printer, here's how you use it, and that's it. But we also kind of go above and beyond, and it might go into further development around right now, what projects are we doing, like, you know, this Tech Tuesday meetup. And it's great to have all of you with us today. We do this monthly in some way, shape, or form, and we change the topic every month, typically following suit with digital fabrication tools and workflows in the classroom. And
I was going to call you about that.
Continue. I just muted someone.
Thank you.
I muted them.
Thank you. So yeah, we do this every month, this Tech Tuesday meetup every month. And last year we started inviting co-hosts on, and the co-hosts could be teachers like yourselves, administrators, folks that are managing maker spaces. Last year we had a gentleman from MIT, and he was showcasing his multicolor 3D printer and projects that were being done on that. And I believe, Kristen, everybody can easily find previous recordings.
Yeah, they're all on the website. Yep. Under our event section, you just need to fill out a form and then you'll get the YouTube link to watch it.
And today we are happy to have Mike Smutok from Uxbridge High School with us. And we chatted a bit with Mike about what he could be covering today, and specifically around 3D printing. Mike, are you ready?
Yes.
All right. So let me stop presenting on my side here. All right. There he is. Now, if you are new to Teams and you want to, and Mike is not actively presenting and you want to pin him, you can click on the little 3 dots in his window and click pin, and it will maximize or like spotlight his screen. And Mike, why don't you go ahead and take it from here? I'm sorry, one other quick disclaimer. While we do these, it's pretty informal. We love conversation, we love questions, and we would just ask that if you do have questions while Mike is presenting, to type them into the chat, and Kristen and I will kind of field those. And Mike, we might pause or stop you just to bring up a question that someone asked.
Sure.
All right, that's it. Mike.
First of all, can everyone hear me?
Yes.
Okay, good. I've got two systems here. I've got a computer system and I've got a cell phone going, so I can move around the room a little bit here. So I'm not used to presenting like this, so we'll see how it goes. I'm always excited to learn something new here. So there's 2 ways that I use this 3D printer technology. The first way would be, I have students sometimes go to this website called Thingiverse, and you got to be careful what you find on here. Some things I say, okay, that's really fun. It's a nice little thing. We can, learn how to use the 3D printer by printing one of these Thingiverse things. There are other things in here that are just really complicated, and I kind of use them as a reward. So I do let students use Thingiverse things from time to time. Other times I will let students use Thingiverse things if it's a part of a larger project. So for example, I
Mike,
have
I'm sorry. I want to stop you for 1 second.
Yes.
Would you mind opening up Thingiverse, or just showing for those that don't know what it is? Just opening up the web page so they can see it.
Absolutely. Hang on 1 second here. Let me
You might need to stop if you just shared Fusion 360. Oh yeah, there you go.
Yeah.
Just reshare your desktop maybe.
Working on it. Stop presenting. Hang on. I'm just gonna do. You know what I'm gonna do? I'm gonna put this on the phone, I think.
Oh, Mike, I can do
we'll
it for you real quick. Yeah, no worries. I can do it for you real quick.
We'll see how this. Oh, all right. So hold on 1 second. Gentlemen, your stuff's on the board. Get after it. Be quiet, please. What'd I just say? Okay. Sorry about that. So yeah, what we're seeing is a website called Thingiverse. I do oftentimes let students use projects on Thingiverse. Sometimes it's a reward type situation. Hey, I found this really cool thing. Can I print it? Other times it will be something that I'll incorporate as to part of a larger project. So what they will do is they will use something in Thingiverse that already exists as a possible solution for a problem, an engineering design problem that they're working on. So again, I do use it. I teach students how to responsibly use the technology and download things and open them up and use them. They go through the entire 3D printing process where they have to take the material off of the website. They have to put it through our slicing software, depending on which 3D printer they're using. And they have to, estimate the material. They have to figure out how much material is in the machine. So that whole process, this is a really good starting point because they don't have to physically create something using Fusion 360 or Onshape, and their CAD modeling skills can be very, very low, and they can still use the 3D printers. I think what Adam's looking for here is some VEX parts. So VEX robotics is very, very common in high school curriculums. There's robotics competitions, there's robotics clubs. It's part of our engineering curriculum at the high school. And if you or your students go and search for VEX robotics parts, VEX V5, VEX V IQ, you'll see that there's a whole bunch of information that's already out there. So you can see the top V5 charging dock that you can see on there is something that our students used as part of our design. So what they did, the problem was we have all this new robotic equipment. We needed a way to effectively charge the batteries. We needed it to be mobile. We needed it to be done relatively quickly. So we had a time constraint. It was also done during a hybrid year. So the amount of time that students could spend working on this was pretty low. So they were able to take a design that someone else had done and incorporate it into some parts of their design and make it work. And it's now something, it's a fixture in our classroom, and we use it. Students use it every day when they come in and they use these VEX robotics. So there it is. There's, as you can see how quick that just happened. While I was talking, the model has been downloaded and inserted into the MakerBot slicing software. It's called MakerBot Print. And he can select a printer and slice it and edit the settings. And that's, again, it's all part of learning how to 3D print. It's not just oh, I downloaded this and I printed. Well, there's a little more to it than that. There's a little bit of understanding what the settings do, understanding what the infills are, support material that you have available to you, things like that.
Let me just stop for 1 second, Mike. Claire just chimed in on the chat.
Sure.
If you're interested in seeing how we use 3D printing in my photo class, we had students model cameras in Tinkercad and then printed them on our sketch printers. Students in Mike's class already knew how to use the program, and they applied that knowledge to my class. So thanks for sharing that, Claire. That's a really great. So Claire is also at Uxbridge High, and that's a really great example of two teachers kind of collaborating or having their students the content in their classroom be exchanged. Mike, do you want to speak to that a little more?
The collaboration with the 3D printers. Absolutely, I can talk a little bit more about that. I have another quick example of the collaboration with the 3D printers. Not so much between two teachers that knew how to use them, but more. I had a teacher from, a guidance counseling secretary emailed me and said, "Hey, can we make a nameplate for the school resource officer who's in the school, but he doesn't really have a desk, he doesn't have an office, but it would be nice if we had a little nameplate." I wasn't sure what she wanted, something maybe from the wood shop, something laser engraved, something 3D printed. We have various options here, so we're very lucky in that regard. I actually had two students. I assigned them this project. It was an extra thing, so if they didn't finish it and I had to do some of it, it wouldn't take off their grade. It was a fun activity for a couple of, kind of like a reward. And I was able to have them design. I did some of the CAD work with them, and then they went through and 3D printed. This is just designed so that a piece of acrylic fits in there, and we laser engraved the person's name. I actually saved the file, and I've used it 2 or 3 other times for other teachers. So it's like the gift that keeps on giving, you know. Speaking of
Mike,
files,
Mike, I'm sorry. Can
yes.
you just what printer did you use for that?
We used a MakerBot Replicator Plus for this.
Okay.
Because it doesn't fit it. I don't think it fit in the sketch with the height. I think it was the way that they designed it. There were not brand new to engineering and design, but fairly new to engineering and design. So I didn't incorporate the printer size as a constraint that they would have had. So I did say, hey, your design has to fit in this printer.
What orientation? How was that? What orientation was that printed? It was just
like
printed
this.
like that.
Built like that.
There were there were support structures, right, in there.
There was a little bit of support in the overhanging areas, but we broke it right off. It seemed to work just nicely.
It looks great. Yeah, it's a great model. This is we could answer this at any point, I think, but Frank asks what the average class size is. I guess when you're doing 3D printer projects, how many printers do you have? And he finds that he'll reach a bottleneck, right? So if you're trying to get all of your students printing at once, how do you work through that?
One of the ways I've worked through that in the past has been limiting the size of the objects that students can print, like putting that constraint on there and saying, oh, your whatever it is that you're making needs to only have a certain amount of material. Depending upon the printer, some printers measure the material in grams. Some materials measure their printer in cubic inches. I will oftentimes give the constraint, it can't be larger than a 2-inch diameter circle. So, and then I'll print a 2-inch diameter circle and say, if your project doesn't fit on there, it's too big. Make it smaller. That way I can print multiples at the same time. And again, the smaller they are, the quicker they print. So it really adds a third dimension, that physical dimension to your iterative design versus I sketched it and now I resketched it and now I made it on the computer. Now I remade it on the computer. It does add that third dimension where people can touch it. They can see, oh, geez, my letters. I had some text on there and I made the letters that are a little too thick. or I cut a hole into something and it's too close to the edge and it broke because it's plastic. We have 1, 2, 3, 4. I have 5 3D printers in my room. I have another 2 or 3 in the fabrication lab that the 8th graders use a lot. We have 1 in the art room, maybe 2 in the art room. Claire, I don't remember. I know you have at least 1. There's definitely 1 in digital photo. There's 2 or 3 in the library. There's several that we've sent to the elementary school. I know our elementary school teacher and our middle school teachers have got some as well. So we try to work deals with local distributors who may or may not be hosting this event to, work on some sort of package deals where we can get the most for our money. So we don't have this just one huge 3D printer and a bottleneck or, when it's down for maintenance, stuff like that. So we try to really think what's the best deal for the students and kind of go with that.
So Mike, let's, I'm sorry to diverge a little bit here, but I love the question's great. And Frank, we may have a little bit of time later to touch back on this. But Mike, when we were talking about what Claire had brought up, you mentioned you had a file you wanted to show us.
Yes. Let me see if I can show this again. Hold on, I have to be present. Hold on, how does this? All right, this is the chat. Open share tray, share Fusion 360. So can everyone see this Fusion 360 screen that's on in front of me?
Yep, it's coming through.
Yep, it's coming through. So here's the CAD file for the nameplate that the students and I designed. Well, I helped them with the CAD, but they came up with all the measurements. They came up with all the design. I just kind of stepped in, filled a couple of gaps from the hybrid year that we're missing. But here's the nameplate design. Here's another project that I've used. I 3D printed this and then I use it as a manipulative for the students to actually take and measure this. And I give them this drawing, a blank sheet, and they get to physically measure something versus, this is how I teach learning how to read a dial caliper and a micrometer and to some extent a ruler, is to have the students physically measuring something rather than just, oh, look at this picture of a ruler on a piece of paper. This here was designed and printed. I want to say it was a collaborative design between different students and myself. And essentially what it is, it's a series of tanks that would be, maybe fake filled with some soap and then some water to rinse off the soap and then maybe a sanitizing agent and then maybe, I don't know, something to dry off a part. And then the part itself, if I turn off this, the part itself is this little cylinder. And what the students did, they designed this. We designed this as a group effort, and then what we ended up doing is 3D printing them and using them for the robotics, for which I'll talk about in just a little bit. I'll show you, what they look like, what ended up happening with the robotics. So, how do I stop sharing? Here we go. So I ended up using that as an idea, from an idea to a physical model in a very, very short amount of time. It's something that people actually still use in the classes, and they get to that kid that designed that's going to come in this room later on in the year. Go, hey, I made that. That's that ownership. That's a really cool feeling for kids.
So that last model that you just showed us was the one designed for the Dobots. Do you mind showing us the physical result and perhaps the I think you took the Dobot out as well.
Yeah, so let me get my class going real quick. So they're not all sitting there looking at their phones.
Yep.
Gentlemen,
you
can take.
Yeah, I can. You want to mute him for Kristen for a minute?
You can take your stuff, start counting the teeth, start working on this. Just do it quietly, please, if you can. Yes.
All right.
Awesome.
Thank you. So while we're waiting for Mike to jump back in here, I'd like to invite anyone, if you'd like to chime in with a question or a comment right now, vocally, please do so. I was just going to show you a couple of photos and projects that I've done while we're waiting. Oh,
It looks like
Mike's actually.
yeah.
Yeah, Mike's
I need,
ready.
I need to unmute. Hold on.
Yeah, go for it.
All right,
There we go.
I think we're back.
Yep.
Yes, okay, excellent. So here's the physical models that we ended up 3D printing of that tank system. This is a pallet that, as you can see, I could have very easily just 3D printed it. However, I wanted to teach the kids how to use some of the other technology that we have. We have a laser cutter, laser engraver. So I taught them how to use that to make this. The pallet would be designed to hold blocks that the robots pick up and do pick and place routines with and for. So again, it's all about physical stuff, small physical things that students can design and print in short order and make adjustments to them if they need to.
And can you show us the DoBot, Mike? Just
Yeah.
to like show people what it looks like.
So a DoBot robot is a small robotic arm with several different end effectors. At this time, I have the suction cup module or the suction cup end effector that's on. I don't know how well this is showing up on the video, but this is not connected to the computer and it's not entirely ready to be set up. However, it just gives you an example of what they look like. They're fairly compact and you can they're fairly relatively cheap. So for the price of a larger industrial robot, you could get several of these and have multiple groups of students working together. That's kind of what we try to do here as we're working with these. So what would happen is the students would program the robot to pick this cylinder up, dunk it in the pick the cylinder up, dunk it in the different tanks, and then place it someplace, off to the side. So that teaches some looping. It teaches some jumping. It's really specific to the robotics. However, it's a lot cooler when you have a 3D printed a 3D printed part that you can actually go through and see. Hey, are my coordinates lining up? Is my jump going high enough? That kind of stuff versus just doing it in open air space. I do have, and I will show you. This is the battery storage that was designed by students using the Thingiverse files. So again, it had to be portable. As you can see, it's kind of zip tied up there right now, but when we do move it, we just undo the zip ties and we take it and we go. So they had to design this to fit the number of VEX batteries that we have. As you can see, they printed it in different, they wanted to change the colors around a little bit. And they had to make sure that all the wires and everything were relatively neat and everything was nicely plugged in. So there's another example of how I'll use a Thingiverse file in my room. Can you all hear that screeching noise? Yes?
Yep.
Cool.
Yep.
But not really, because when you have a whole class working with these, that's all you hear. So several students, again, got sick of that problem, and they designed and printed these tiny little 3D printed feet, if you will, that fit on the end of these metal plates. So if I slide it across the table now, it gets rid of that issue. And I've got a whole box full of them that students can pick and use on their, so it doesn't have to be something really grand and huge and awesome. It can be something as simple as this, these little feet that makes all the difference in the world. Like I said, there's 4 or 5 students that worked on messing around with this. And every time they come in this room and they see one of those, they go, hey, I made that. Hey, I made that. That's really cool. Other things that I'll do as the students progress in the engineering curriculum that we use at the high school, 3D printing is, I don't want to say lost or forgotten, but it's not as emphasized as it is earlier on. So what I'll do is I'll interject 3D printing and design work into their projects. For example, we make a robotic machine that sorts marbles by different colors. I've added a constraint in there that makes sure that the students have to 3D print at least one part of their design. Must be 3D printed. Some of them are really simple. That's not that difficult to design in 3D print. All this was is just a flipper mechanism that allowed one marble to go down a chute at a time. Some of the others are a little bit more complex. They involve some more difficult to understand and mess with geometry. They have to design around constraints. So this square hole here has to fit the certain axle part that and they get a couple of times to test and see. And, as you can see, this one has a marble in it that is, they had to design around the little opening around for the marble.
Looking for those little screws for these.
Toolbox they're in there. Toolbox is right. Oh, there's no more. Oh, yeah. Get a toolbox out of there. Sorry, my students are working on projects here. So another little container that students designed so that the marbles don't go rolling all over the floor. So they can actually take this and bolt it onto their project, and it just holds the marbles while they're doing their testing. So something as simple as that, all the way up to. This is a fairly complex design that students worked on and then 3D printed. And if we had more time last year, I would have had them iterate this design one more time to make sure that they weren't filling in gaps with wood and they weren't using strapping to hold the thing down. But essentially, this is a parts feeder. It's a gravity feeder. At the end of one of the students create a factory system where they have to, the only things I tell them, I said, it has to be an autonomous factory system. And it has to use different robotic components. So here we have some VEX components and a DoBot. So it can't all be the same thing. And what they're learning to do is use the design process, work collaboratively as a group, troubleshoot, and program and troubleshoot the programming for different components. So what these students came up with was an idea for a gravity feeder. They did some research, they found other designs, they looked at industrial versions of this, and they made it work and fit with the pneumatic system that we have at the high school. So essentially these blocks, which come with the DoBots, you're gonna get, if you buy a DoBot, you'll get 50 of these little colored blocks that you can use to, do your pick and place routines and move all around. This group of students designed this gravity feeder around this block. And so that when a signal went to this microcontroller, it fired the piston, sent the block out the front. Then it sent a signal to the DoBot that would say, "Oh, okay, the block's there. Go pick it up and move it on to its next station." So what you're seeing here represents roughly a month's worth of work in a high school, and it was a really fun thing to do and try to troubleshoot. It's something that builds resilience, in our students to try to have to go and do this. But I really enjoyed it. I think the kids really enjoyed it.
Mike, this is great. Thank you so much so far. We have a question from Vaso. He asks,
Yes.
What grade are the students that work on the marble sorter project? Is this their
10th grade.
first semester work? And is it the first semester working with 3D printing and VEX?
It's their first time working with VEX, but it's at Uxbridge. Their students will get exposed to 3D print a little bit at the middle school, a little bit in 8th grade, a little bit in 9th grade, and again in 10th grade. That's why I added that into the curriculum. Again, it's because they'll forget it. And then the factory system was 11th graders, and seniors do capstone classes. So they have basically what I tell the seniors when they come in for their capstones is, hey folks, you have been through the progression of engineering classes here, all the way from middle school on up. You may or may not be an expert in something, but you have access to use whatever you need to work on your capstone project, whether that be laser cutting, 3D printing, CNC machining, because we have access to some of those types of things as well. And I just I don't want to say turn the students loose, but I give them full access to all the machines and all the equipment that we use, including 3D printers. Matter of fact, I encourage 3D printing for your prototyping because it happens very, very quickly.
And what,
Here's another
Mike,
example.
I'm sorry, real quick, what printer is your workhorse right now?
Ooh, that's tough. that one's going a lot. It's the reasons that this one goes a lot is because the material is relatively inexpensive. You have a pretty big building area here. It's relatively quick. I don't have a problem. I don't have to worry about things. If a print fails, and if I print a 10-hour print and I leave it overnight and a print fails and I come in, it usually doesn't eat up a lot of material. We have a couple of MakerBot methods. Those are probably not the next one I'm going to because they have a pretty small build area. Our big workhorse, other than the MakerBot Replicator Plus, is, and I'm going to go pan over all the students that are working here, is that guy right there. It's a Stratasys F170. That printer runs a lot.
Yeah.
Because
And the method and the Stratasys printer both have soluble support filament.
yes, they do.
Right. And do you use that? Do you do you take advantage of that feature a lot?
I do, especially when I'm printing things like this. This is another one of those, hey, rather than look at this picture and try to sketch it and design it, I'm giving you the physical model. That really, really helps with students, especially if you have students with, varying needs, is to be able to have that physical part. Something as simple as different hole types. That was printed on a, I believe this was printed on a Stratasys because I shelled it so I would save material. Something as simple as different hole types. This is something I pass around to the students. I can sanitize it, I can clean it. It's plastic. If a kid wanted to, needed extra help understanding it, here, let's take a look at this. Let's, now you can really see the difference between a counterbore and a countersink and a spot face and a blind hole and a through hole and all that kind of stuff. So I use it a lot for teaching aids as well. Like, as you saw, I had this model up earlier on the Fusion 360. Here's the document that I give to the students. So they have to physically manipulate something in order to help them learn. And I find that doing that without a 3D printer is a little bit tricky.
That's great. I think that covers everything that we kind of talked about going over, Mike. I do. We have like 20 minutes left. I wouldn't mind, and this is something you might be able to speak to, Mike. I wouldn't mind doing showing off one thing on my side. Is there anything else you'd like to? Yeah. Okay. Let's see here.
No, I think I'm good.
Great.
I think I stopped sharing.
I want to, so I want to talk a little bit about, well, I guess this kind of leads into a couple things. One is the actual physical properties of a 3D print. And Mike, I want you to chime in at any point here, because I think this is a really good topic that could be discussed with students. Let me bring that back up. And I want to show you exactly what I mean by this. So what I'm showing you here is this is just a sample kind of armature here, and I did this just to showcase a file that was water jet cut. So this component here I cut with a water jet out of aluminum, and then these blue portions are 3D printed. This axle is actually a 3D printed screw axle. And this is a little more advanced, but if you're working with your students, maybe upper high school, and, sometimes you folks will surprise me and be like, oh, my middle schools are doing stuff like this, and which is great. But let me just show the cross section here. I might be, there we go. Yeah, I can just take this part out. So yeah, so this right here is a bolt and kind of like a closed nut and bolt. And if we look inside of it, and this is a nice opportunity to use any CAD software will have a cross section feature. And Mike, I'm glad you showed us that drawing, because I noticed that your drawing had a section view, which kind of translates right into our CAD software here. And in here, I can go in and look at my threads and the distance, for example, between you know, the end of my thread and the inside of the nut itself, to kind of talk about how could is it practical to 3D print a nut and bolt? Does that make sense? I'm not going to get into that too much. I just want to show you that part. What I want to focus on more is actually this plate fixture here. It's not a super solid design, but let's take a look at this. If we 3D print it, we turn it into a physical object, is it strong enough? And are there orientations that we can print it in order to make it stronger? And Mike, I wonder if you talk with your students about how orientation has a bearing on rigidity of, you know, of a model. And right now,
that entirely depends on the time that I have. If I have the time and the material to let the kids make that mistake, I let them make that mistake.
Yeah.
If I don't, then I step in and I say, okay, listen, we need to talk about the orientation here. We need to talk about the different printers that we have. That F170 printer has the option to print a much more solid print than the. I mean, you can do it on the MakerBot replica. It just takes a really, really, really long time. So, you know, is it something that needs support material? Is it something that we can do it without support material? How do we best orient this in the slicing software so that we get the results that we need with the least amount of wasted time, wasted material, that kind of, like, I would probably not print that piece in that orientation because it's going to take a lot of support material. Yep. I would also take a chance and look at this and say, okay, let's look at our infill settings on this. And, you know, is it a prototype that we're going to just look at and see if it fits somewhere? Because if it is, then we can use a smaller infill. Is it a model that's going to actually have forces applied to it? Then we need to maybe change our infill settings. You know,
yeah.
So that's how I use it.
Yeah. One thing that that I find really interesting that I wonder if you know the teachers are talking about is, so right here, if we take a close up, this is our simulation view in our slicing software. This is specifically for MakerBot printers. But you can see here that we have, if I do a side view, we have layer by layer, right, climbing up here. If I go all the way down to just before the kind of protrusion starts printing, you can see that there's actually, you know, it's actually laying a perimeter layer on top of this part here. Now you would imagine that if I put enough pressure on this, you know, of course this is just melting, you know, plastic together, but it's still like stacking like layers on top of layers here. And there is a horizontal, there is kind of like a little bit of a structural instability when you print something like this, because if you put pressure from horizontal pressure on this component here, it would be more liable to break because of this stacking here, and this actually hairline right here, right? Even if we did put a lot of infill in there, the probability is still there. And what's interesting is we can actually, you know, talk about how would we change that with simple printing orientation. And if I orient to the side here like this, and we do a simulation. Now what we have is our perimeter wall is actually a continuous bead of plastic. So the tool head will come down and do this perimeter, and it won't stop when it rounds this corner. So we will actually have a little bit of added rigidity just based on flipping that orientation. And of course, yeah, in some cases that actually might result in you know, a lot more support material maybe, but where do you call it? Where do you say, well, we really need to print it in this orientation, you know, because of that rigidity. So, but yeah, I was just thinking about that with some of the designs you were showing us and my own kind of practices here. I also want to go back to Frank's question earlier with like a bottleneck. I've been here too, right? So you have 2 3D printers in your classroom, maybe you have 1, right? And you're trying to integrate 20 students, 30 students, you know, getting prints done. And Mike already gave some great suggestions there. And one thing I wanted to ask you teachers that are regularly incorporating 3D printing is, do you ever find the opportunity to enlist a student like who is kind of like demonstrating an advanced proficiency with 3D printing to kind of assist you in creating batch prints and like getting the class's prints going? Is that something anybody's doing, or do you have student candidates who might be able to do something like that? Yeah. Mike, are you doing it? You're muted right now.
How's that, better? All right, yeah, I've got several students that have 3D printers at home. And again, the slicing software may be slightly different, but again, that's a 21st century digital literacy skill, is to be able to switch between 2 different but similar interfaces and be able to figure them out and use them. So a lot of times I'll have students run those batches of things. If a student wants to print something for their project or wants to print something, I'm not the one that does it. I stand behind them and show how to do it. I don't have. On the flip side of that coin is you got to be careful with which computers have the software on them for slicing and sending to the printer, because if not, once the kids figure that out, you'll come in the morning and they'll be like, you know, stuff printed that you didn't want printed. So just, you know, every school's IT is going to have a different input on this, and whether they're going to network the printers or whether you're going to use the USB drives and the sneaker net across the floor, you know, to go plug it. I use that method because our IT didn't want these printers on the network, and I said, okay, fine, that's cool. We can work the other way. We can work with the USBs, but I'll have students, they go in my drawer and get a USB. Let's go over to this computer that's got, you know, MakerBot prints on it, and let's log in and I'll show you how. We'll go through the process and we'll talk a little bit about that, you know, that layering, that kind of stuff. The kids will export, the kids will walk it over to the printer. The kids will, you know, make sure the build tray's clear, set it all up, print it. I'll leave it on there, and the kids get to come in and peel it off and yep. The kids get to do all of that. Oh, hold on, I got an announcement here.
Sure. So Frank, if you're still with us, I'd love to ask if this is something that you are doing in your classroom. Are you there? Are you interested in jumping in audio wise? All right. Well, if you are,
no,
Frank,
I am here.
Oh,
I'm sorry.
wonderful.
Can you hear me?
Yeah, I can hear you. Great.
Great. No, thank you for answering the question a couple of different ways. So I have 2 Ultimaker printers and I have a Flash Forge, and my students do go through a bit of a rotation. They'll all go through the loading and unloading process. They'll go through any of the slicer software. So we do have Cura that we use. And as we go through that, going through with 20 students, there's a little bit of a rotation, and I do try to look for those leaders within class, the ones that have that kind of expertise. But it was very nice hearing that many schools have more than just 2. I know that we have 3 in my room, but 1 in the library as well. And when they are down, that really is a little bit of a balancing act. Like, we're currently printing accessories for a play on Mr. Potato Head, but it's for pumpkins, and we're decorating them for the season. So these prints can get quite lengthy, 12 hours, 13 hours. So I try to balance what that time looks like. And then we have another class where we're printing 3D coins, small little quarter-like images. But again, it's that balance between how long is this print going to take, and is it going to run overnight, and have they added the right supports? Is the build plate too big, and are we going to run into issues? Because we've had that happen, and you come in and it looks like spaghetti all over the printer. So it's
Frank, what grade are you teaching?
So I have the 9 through 12, and it's a high school level.
Yep. Yeah, I mean, I think that if you're kind of seeking out some candidates who are already going above and beyond, or just demonstrating some adept interest and knowledge of printing, just kind of start bringing them on the technician side, and kind of tasking them to assemble prints and reject. This one opportunity I think about with this is, if you have a 3D printing technician, one of their jobs is to reject prints. So let's say Mike has a student who submits a print to him, or submits a print to a big project, like, doing like 20 prints on a print bed or something. And the technician sees that, oh, wow, this is oriented incorrectly, or I can't print this. It's like this geometry is going to produce spaghetti or something like that, that they reject it. And they actually don't even include it in the print. And the student has to understand that that's a crucial part, and that they can't actually go through the production process until they go back to the drawing board in their CAD software and repair it. So that's that's definitely a doable workflow.
I love the idea, and thank you for sharing it. Thank you for putting these events together, because I have found them very valuable.
Oh, thanks, Frank. I appreciate that. I also want to jump in with a previous comment Claire added with respect to Claire is doing art, right? I believe mostly Claire, right? You're doing art classes. So she has, when Mike was talking about just, kind of like printing peripherals, she was saying she does the same thing in sculpture class, that she has at least one piece of her dioramas she did with her students 3D printed to scale, like chairs, couches, lamps, plants even, which is awesome. And that's another thing that I myself have dabbled in a little bit, is using 3D printing for art projects. And that's something that I would encourage you folks that are strictly engineers, or maybe you're strictly being told you need to use 3D printing for engineering, that if you have art teachers that are interested, or design teachers that are even remotely interested in 3D printing, it's a great opportunity to bring additional staff in that might open your mind to different ways that you could use. Like that plant holder Mike's holding up. Awesome. Yeah, great. I did something once that was very experimental. I was working with an after-school program, and we used something like Tinkercad, and we designed and 3D printed sculpture tools. So we actually just made custom clay sculpting tools, and they were okay. But what's interesting is that you need to do finishing work with stuff like that, which is another cool application for 3D printing. A lot of us think that it's just the machine does the print and it's done, but there can be a lot of additional work done. Like you can use different grades of sandpaper to smooth out a print. You can apply like a clear coat finish to it to smooth it out even further. Paint it, So yeah, that's pretty neat. So anyways, thanks for sharing that, Claire. Appreciate it. Basso is asking, what is your budget for 3D printing materials for the year? That's a great question. Mike, you want to answer that?
Yeah, our budget for 3D printing materials, let's see. Admittedly, it's a little higher than some other schools because I put a pretty big emphasis on it. I also try to find like deals and that kind of stuff on some of the materials. Not the stuff that I run through the MakerBots, the stuff that I run through other printers and whatnot. Some of it has to come, like Stratasys has to be a Stratasys 3D printer plastic because of the way that it's loaded into the machine. It has an RF chip in it that keeps track of how much material is actually on the spool. Some of the MakerBots do that as well. The MakerBot method has an RF chip inside of it too that keeps track of the amount of material on your spool. So it is proprietary. I would say I probably spend maybe $1,000 on 3D printer material. And for some schools, you're like, well, that's my whole budget. We got really, really lucky over COVID, and we somehow managed to get some sort of COVID money from something somewhere. And the principal sent to me, hey, can you use 3D printer plastic, put an order together? And I did, and I got it all. So like it's out there. I know there's grant funds, there's grants that you can ask for materials and stuff like that. I don't want to pitch the teacher GoFundMe stuff, but I will pitch the teacher GoFundMe stuff. You know, get the 3D printer plastic, and you can use that. Yeah, that's kind of what we spend. The deal is with us too is if a student wants to make something that's for the school or for a class, they don't have to pay for the materials. If a student comes in and says, Mrs. Smutok, I really want to print this, lightsaber that I found on Thingiverse for like a Halloween costume, or like I've had a bunch of kids do stuff for what do you call it, Comic-Con. They print props and stuff like that. They do. I use this as a teachable moment and have them do a cost analysis sheet where they figure out the amount of materials, the price per material, and then they figure it out and they pay, and that goes into a revolving fund that can go and replace the materials. So,
Mike, how many students do you have for $1,000? How many students per semester, per year, whatever?
For a semester, well, for a year, I would say probably 200.
Oh, wow. Okay, that's a lot. Thank you.
We have to wrap up here. I wanted to just share a link quickly.
You got the calculator there, Mr. Gage? You got one? I don't know. Claire, did I miss anything? Sam, did I miss anything?
I don't think so.
So I just included a link to our Find an Event page. If you scroll down on that page, you can watch previous recordings of Tech Tuesdays. Just click on one of the reporting links, and then there will be another link that says watch the recording. You'll have to fill out a little bit of info. One thing I'm excited about is Mike expressed to us doing a in-person Tech Tuesday meetup, and this is something I'm hoping to get us moving on more. We do have kind of our first full day Tech Tuesday workshop coming up, and that is free for New England educators. It's located at Nathan Hale Ray High School in Moodus, Connecticut. And I can give you a link for that as well. And this has limited seating. So if it's something you are interested in, it's on November 2nd, so coming up soon. And it is all about kind of just an intro to CNC milling using Tormach mills, which is a brand of mill that we sell. I understand we just gave a try to schedule this on election day, possibly thinking that some folks might have PD days or time off. So it's an opportunity. It might be a bit of a trek for some of you, but if you can make it, it's going to be a great workshop, I think. And this will be with an engineering high school teacher. I think that's it. I want to thank you all so much for being here. Mike, thank you very much for making this happen and helping us out. It was a great presentation, some great projects. All right. And yeah, we will hopefully reconnect with you guys soon. I'd love to come by again soon, just physically to, visit the school and talk with you folks a little bit more about what we can do down the road.
Yeah, I put my email in the chat. If you're from Uxbridge, you probably know who I am. If you're not from Uxbridge, I put my email in the chat. So if you have any questions or anything like that, reach out to Adam. Feel free to reach out to me. I'll share any resources that I have. Yeah, so thank you all for letting us do this with you.
All right. And Kristen, as always, thanks for helping stage this and pull it together.
Thank you. Bye, everyone.
All right, take care, everyone. Until next time.
Thank you.